Hans, and I mean, it's a pleasure to be here. So I will start immediately with questions. That's what, trigger innovation. So can we trust, we talk a lot about Postgres, but can we trust to run uh, Postgres in Kubernetes for day two operations? And can we also migrate our Postgres databases from anywhere, including public DBAs, to Kubernetes with almost zero downtime? So these are some of the questions that I normally, get when I talk about running Postgres in Kubernetes. So let's see what happens today. So welcome everyone to my presentation about the past and the present and the future of CloudNativePG. And my name is Gabriele Bartolini, and I'm Vice President, Chief Architect of Kubernetes at EnterpriseDB. So if you don't know, EnterpriseDB is one of the major contributors in Postgres history. Okay, so we've been around for about 20 years. And also, even though I joined EDB 4 years ago, I've been working in this space since the year 2000, but professionally, when I co-founded Second Quadrant in 2008. So since 2008, I've been actually a competitor of EDB for many, many years, especially in Europe. And now I'm really happy to be part of the big EDB family. And together with the former Second Quadrant contributions and EDB's contributions, we have a lot of Postgres code. So especially the business continuity stuff. We've written code for replication and disaster recovery, continuous backup, synchronous replication, physical, logical replication, and so on. I'm a Postgres contributor, and I'm also a Data on Kubernetes ambassador. And all of these comes from my DevOps background. So DevOps and lean methodologies have really changed the way I've started to see IT. Okay, that was about almost 15 years ago. And the DevOps is pretty much the DevOps culture, what I used to call, because now we talk a lot about platform engineering, but to me, it's about the culture that then makes you produce actions and decisions. Okay, the DevOps culture is what led me to Kubernetes, and what I always say, it's probably the reason that will let me go away from Kubernetes and adopt another technology one day, like I've done in the past. I'm one of the contributors of Barman. Barman is a very popular backup and recovery solution in Postgres, but now I've moved to CloudNativePG since 2022 when we released it open source, but the actual project starts in 2019. But I'll go through it. So this talk is about going through the past, the challenges we've had in the past with cloud native databases, then the current situation, and what I try to push for the future in terms of ideas. So, of course, I mean, I will not go over Postgres a lot, but the idea is that we are talking about probably the most popular open source database in the world. It starts as a transactional database, but thanks to the way it was designed initially, that is to be extensible and customizable, it's been able to renovate itself continuously. So learning from the industry, learning from what was happening in every era of information technology, and bring it inside the engine. One example is JSON, for example. So JSON support in Postgres is very good. One of the key capabilities of Postgres is ACID compliance. So you can have transactions. And we'll see that there's one particular feature that is called transactional DDL. So DDL is data definition language, is what allows you to create tables, manage the schema in a database. And in Postgres, that's entirely transactional. So you can start a transaction, change a table, and then roll back, and nothing changed. okay? And there's obviously a strong community. So let's go with an analysis of the operators. I mean, CloudNativePG is not the only open source operator for Postgres. Of course, this is my biased view. I mean, it can't be anything but biased because I'm a founder of the project and I'm a strong believer of the direction we've taken since day one. But at least, this is all, in my opinion, objective. My advice is to look at all of the operators that are out there, because in terms of features, they are pretty much all the same. CloudNativePG has taken a completely different approach, both in terms of technology and distribution. So technology, we are pretty much the only Kubernetes native Postgres operator. What I mean is that we don't use any external failover management tool that is able to understand the primary and standby architecture of Postgres. Although I have been a developer of Rep Manager, which is a popular failover manager in Postgres before Patroni. So it was started roughly 15 years ago, Rep Manager. Instead of using Rep Manager or Patroni, we decided to teach Kubernetes how to handle a Postgres cluster so that the status of the Postgres cluster is in Kubernetes itself. So we don't use Kubernetes as a proxy to etcd like, for example, Patroni. So Patroni uses Kubernetes, but the source of truth is etcd. For us, the source of truth is Kubernetes. Okay. The other thing is we directly manage PVCs. There's a page in the documentation that explains the decision, but it's primarily because stateful sets for us were a big limitation for handling. We wanted to own the volumes because volumes are the most important part of a Postgres database. So we wanted to have full control, but that doesn't mean that we have abandoned Kubernetes. It's our goal is to work directly with Kubernetes storage. Okay, so we are pretty much the only operator that is tied, that is working with CNCF text storage and also SIG storage with Kubernetes. Yesterday, Kubernetes 132 was released, and if you see there's volume group snapshot support, EDB heavily contributed to that. The reason is that we want to have CloudNativePG support volume group snapshots, because when you manage a database, you have a volume for Postgres, a volume for transactional logs, maybe a volume for each table space you want to use. And with volume group snapshots, we can defer the storage class to take consistent snapshots of the group of volumes, okay? So this is what we're doing in terms of technology and community involvement. The other important thing is the governance. EDB created this project. EDB is the major maintainer behind this project, but EDB donated the intellectual property to a vendor-neutral and openly governed community, which at the moment is the CloudNativePG community, but the goal is for this to become the CNCF. So we recently applied for the CNCF sandbox in September, and by January, we should know if the project is admitted. Then in terms of commits, I mean, you look, I mean, the average is about 800 commits per year. I've been measuring the last 2 years only, okay? And starts, I mean, now we are, since September, the most popular Postgres operator, and this is the trend based on the organic growth of GitHub stars. I mean, it's clear we don't do any publicity here. You know, we don't go and say you win a book or you win a PlayStation if you add GitHub stars, okay? So it's all organic. So to recap, CloudNativePG is also adopted by important players like IBM, Google Cloud, Azure, Akamai, Tembo, and Nova Nordisk is another recent adopter of the project. The list is public, so you can find it. I was saying, you know, it was open source in 2022, and we're undergoing the CNCF sandbox, but the project was started in 2019. We support multiple installation methods. There's Kubernetes manifests. You can also use with customize and so on. Helm charts, operator hub, so operator lifecycle manager. Another important point is the 60 million downloads on GitHub. This is a testament to the vision we had behind CloudNativePG to use it inside pipelines, automated pipelines. So our goals with this project is to enable automation, enable infrastructure as code, enable platform engineers to easily deploy and test the solutions before they go into production. So let's start with the past. I always use Kelsey's tweets, which made my life very difficult in the past, you know. That's been my life at the start, you know, that, you know, when I was telling, you know, use this in Kubernetes, no, the normal answer was everyone knows you shouldn't run databases in Kubernetes. I mean, the good news is that Kelsey was right back then, and he also changed his mind a couple of years ago, 2 years ago, roughly, and things are, you know, are now in a much better shape, and we'll see the database workloads are now the #1 workload in Kubernetes. But there's a reason why Kelsey was thinking that. Here, you know, I've got a recap of the history for Postgres in containers. You can see Crunchy Data was the first Postgres operator in 2017. Then, you know, stateful sets were introduced. Okay, one thing, okay, the operator pattern. The operator pattern is fundamental because another question I'm asked is, can I run Postgres as a container? The answer is no. I mean, you need an operator if you want to run Postgres. Okay, so this is an important statement. If you want, we can cover in the questions, but hopefully you'll see why during the presentation, this is nowadays, you know, the foundation. I mean, you need an operator to run a database. So stateful sets were introduced in 2017. Then another important operator was the Zalando one, was released in 2018. But what really changed the game for us was version 1.14 with the introduction as GA of local persistent volumes. So this is when at second quadrant, we said, now it's time to look at Kubernetes. And we started as a fail fast initiative to determine whether it was worth investing in Kubernetes. And the use case we adopted was to run benchmarks on bare metal Kubernetes. So what we did, we got a Hetzner machines. We deployed them the way we wanted. We ran benchmarks of Postgres on physical machines, and then we installed Kubernetes. We used OpenEBS at the time as local storage, and the results were amazing. I mean, it was just the story on the storage side. We were pretty much at the same level as bare metal, and on the Postgres side, we had kind of 5%, between 5 to 10% penalty, which is nothing compared to VMs, you know. And it was, I mean, we didn't do any optimization. So we said, hang on, this is already enough for us to justify this project. So the idea was, if we can cover the most extreme case of running Postgres on bare metal, with just dedicating one node for a database, we're fine. I mean, we can cover the whole spectrum of shared databases with shared storage, up to the most critical one with dedicated physical node with physical storage for a single database, for a single instance. And that's when we decided to go. And obviously, we evaluated all the operators. Our approach was that they were trying to bring Kubernetes to Postgres people. Okay, we had CKAs in the team that were struggling to install those operators, and we took the decision. We made the decision to think about something designed for Kubernetes administrators. So our audience was Kubernetes administrators. How can we bring Postgres to Kubernetes administrators? And that's why the second quadrant operators were born. Then EDB acquired second quadrant. And I'm really glad about the decision that EDB made at the time. They already had some operators, and they evaluated what we had at second quadrant, and they chose to continue with our operators. So we launched the closed source operator in 2021, and then we decided to open source that. So if you actually look at the source code of the operator, we made a lot of work. We did a lot of work to preserve the history. We didn't want to do like we did with Barman, that at some point we said, okay, now we open source it, and we did a commit version 1 that had, hundreds of commits in the history. We have the whole history here of the project, including the change of license and the change of ownership, which is important. In September, we submitted for the sandbox, as I said before, and then we became the most popular operator in terms of stars on GitHub in October. So this is my view about the evolution of Postgres since the start. Okay, at the start we were using Postgres on bare metal. Okay, then VMs came, and everyone thought, I'm not gonna ever run Postgres inside a VM. And then the rest is history. Okay, now everyone uses Postgres in VMs. Then the cloud came, infrastructure as a service. We started to use EC2 machines, for example, to deploy Postgres as VMs there. But these were primarily day one operations for the database. We still had to manage database with DBAs. Then DBaaS solutions came, and in the cloud, and they were covering day two operations. So DBAs were no longer responsible for ensuring that backups would take place, or that a failover should have been controlled, because the DBaaS solution was responsible for that. And nowadays, we are in the position to achieve all of these day two operations with CloudNativePG. And so when I mention CloudNativePG, I mean the entire stack based on Kubernetes, CloudNativePG, and Postgres. We can achieve what I call cloud neutrality. So we can have cloud neutral Postgres. You can have a solution that you can place everywhere with minimal changes, primarily the ones that change the cloud provider part. Okay. So this is where we're at. And all of these can be integrated in GitOps. So for change management, all the benefits of using immutable infrastructure, immutable containers, all of that, they all come with this stack. And I recently wrote this blog. So if you're interested, you can look for Cloud Native Postgres on the CNCF blog that recaps all my ideas behind this concept. And this is primarily what I've witnessed for a long time. So when I talk to Kubernetes people, normally the idea is to place the database outside Kubernetes. So it's either on bare metal or VMs, or in the public cloud, so using IaaS and even the DBaaS solutions. The idea is to I run my application inside Kubernetes that connects to a database that sits somewhere else because, I don't want to deal with the database. And fair enough. I mean, I would never go back to VMs or bare metal, just to be clear. I mean, to me, Kubernetes right now is the best way to handle Postgres. So the present now is completely different because we're talking. This is Michelle. Michelle, I had the pleasure to give a talk with her at KubeCon in Chicago last year about disaster recovery of very large databases, in which we showed how to recover a 4.5 terabyte Postgres database in 2 minutes. Okay, so she talks about petabytes. Okay, in Kubernetes. Oh, this is Piotr, CTO for we work with Piotr on the IBM Cloud partnership with EDB, and they have pretty much all IBM Cloud PaaS stuff runs on our operator. So there's actually a full story. You can read it there if you're interested on what he says. And this is a recap of the first 10 years of Kubernetes and where Postgres stands. So just if you want to have more background information. So at KubeCon, I participated in this panel about the future of DBaaS in Kubernetes. And as part of the Data on Kubernetes community, we presented this report that says that database workloads are this year as well the #1 workloads fueled by AI as well. So there's an increase of AI, but because AI needs data, it's increasing the adoption of databases in Kubernetes as well. So I was mentioning cloud neutrality, okay, with Postgres. This is our opportunity right now. So basically, you can leverage the portability that comes with Kubernetes, and you can do it even on-prem. There's a return of on-prem because they provide more cost predictability, for example. And there's more responsibility, but there's more control, and there's things like data sovereignty and data portability, all aspects that are very important. So I've seen in conversations lots of interest in bringing back data on-prem. Okay, the good thing is that you can have CloudNativePG manage both internal or external DBaaS solutions. So if you want to provide, because you still have applications and infrastructure teams managed separately, you might want to follow Conway's law and pretty much provide a service to the application people in terms of databases. So they might come to you and ask, can I have a Postgres database? And you provide that. So this is done internally, but customers like users like Akamai or Tembo or even EDB, they provide database as a service solutions for their end customers. So again, all the infrastructure as code capabilities come with this stack. And you can simply rely on streaming replication. The European Data Act that is law in Europe, it fosters data portability. If you rely on CloudNativePG, you can have hybrid cloud, you have multi-cloud, you can just use streaming replication to transfer data between different regions, different Kubernetes clusters, and so on. Even do multi-cloud. And it is all based on the concept that Postgres databases must be treated a bit differently from any other application. So I use always the analogy, we are used to a cattle versus pets. What I say is that we are more similar to cattle than pets, but we are elephants. Elephant is the logo of Postgres. So what we ask is for some special attention, which is nothing but more attention on the hardware side, on implementing shared nothing architectures possibly, not rely on storage storage replication for state synchronization, but just rely on Postgres, because Postgres has a native and very advanced system for replication. So it's a different concept, but you can also run on bare metal with local disks, as I was saying before. The idea is to isolate Postgres workloads from the rest. So that's the only special thing that we ask. And if you do this, you're free from any vendor lock-in form. So this is what I was mentioning before. If you run on bare metal, you have more performance, okay, and more performance predictability in general. You don't have this layer that sits between the process and your machine. And this is a recap of the main features of CloudNativePG. I'll just skim through it, but I mean, you can just go through to the web page. I mean, all the features that are required for business continuity are there. And my favorite one is definitely the replica clusters that allow you to do disaster recovery solution across and across regions and across Kubernetes clusters. This is an example of how CloudNativePG works. It defines a cluster resource. So in this case, I create the Clapton cluster with 3 instances, meaning you've got a primary and 2 standbys. I request to install to prevent the installation of the Postgres instances on Postgres nodes. I request synchronous replication. So with the synchronous stanza, I say, I want any of the standby, but I want at least a synchronous instance. So when I commit a transaction on the primary, I want to make sure that also at least another standby has written the transaction. Okay, so this enables RPO0 for high availability. And then I want 2 volumes, one for the storage and one for the transactions. This is what happens. So suppose you've got 3 availability zones, you've got the Postgres nodes, the operator creates the PVCs. This is what changes. I mean, we create the PVCs first, okay? So the PVCs lead where the pods run. Then we create the primary, we create the read-write service that points to the primary. Then we create the first standby and the second, and we also provide a read-only service. There's also a read service if you want to be randomly connected to any of the instances. So in case of failover, let's suppose there's a problem on the first node. Kubernetes pretty much immediately detects the issue and detaches the read-write service and then promotes the closest standby. And then if all the primary comes back, it is demoted, and it follows the new primary, and it is part of the read-only service. So this is currently the most typical use case of the operator. It's a DBaaS approach, and primarily it's an internal DBaaS. So you have your application in a Kubernetes namespace, and you create a Postgres cluster either in another namespace or in another Kubernetes cluster. That really depends. Okay, I've seen that infrastructure people prefer to keep the database not that close to the application. Okay. And this is just an example of the symmetric architecture that with replica clusters and distributed topology you can achieve with the operator. So you can use Postgres replication to copy data and have already a ready to be promoted Postgres cluster in another Kubernetes cluster, which is normally a region. If you want to know more, this is another CNCF blog article that I wrote that explains this. So the future, it's about the microservice database. Okay, and we are not seeing much implementation, to be honest, because I think it still needs to happen. Okay, but I think that this is a possibility, an opportunity for all application developers to own the database. And again, this is part of the Streamline team. Okay, if you are familiar with the platform team, we should also understand that the platform team needs to help streamline teams in an organization. Okay, so the idea here is to have your organization write an application. The opportunity you have is to put a database as part of your application and use Kubernetes to test and to be a high-performing organization that has several deployments a day. Okay, in continuous delivery and continuous deployment. So the idea is to create kind of a highway between the developer and the end user. So for example, you write code for your application and you have your Postgres database. You run end-to-end tests locally using kind. If it works, you just push on GitHub, you create a pull request. This is, version control is a DevOps capability from DORA, okay? So I'll mention a few of them here just to show where they sit in this workflow, okay? There's a pull request. You use automated pipelines to test the patch, so test automation. You also scan the code, scan the images that you build, and you use the artifacts that you build as part of your feature development to run tests using kind. So the same kind solution that you run on your laptop runs in the pipelines to make sure that you don't introduce any regression on the trunk. Okay, and you can use database change management because of the transactional DDL capability that I mentioned before to add changes as part of the migration when you deploy a new feature. So you merge on the main branch, so on trunk, only when tests pass. So you are in continuous delivery and you follow trunk-based development. Then when you want your release, you push the container image and then you deploy on the same environment that you've used pretty much for the test. Okay. So this is ideally the opportunity that we all have, and we have the possibility to have early feedback on your local environment, or still early feedback following the pipelines. So the future again, the CNCF sandbox submission. Let me check the time. Yeah, okay. So this is something that we did in September. If you want to support us for this is very important, because if we are approved, CloudNativePG will become the first Postgres operator to enter the sandbox for the CNCF. And the idea is to become graduated in, let's say, 5 years' time. It could be a kind of a visionary goal or for us, And in terms of roadmap, the bold items are the ones that we are delivering in version 1.25.0. A few days ago, we released the first release candidate of 1.25.0, and we have the database resource. So if you want, you can add more databases to Postgres, even though our recommendation is to just use one database per instance and implement the microservice database. So just to be clear, the microservice database is a database that is owned by a single application. So for several reasons, primarily for backups and resource control, it's better to dedicate one instance for a single database, okay? Because historically, we would create more database in a single instance because it was complex to install and deploy a Postgres cluster in business continuity with MTLS and all of that outside Kubernetes. Now it takes 20 seconds, okay, to do it, and it can be automated. Okay, so there's no reason to say, I want to put more databases inside. Also because it's not possible to connect to those databases, within a query. Okay, so anyway, but if you want, you can use the database resource. The important ones are publication and subscriptions, because I wrote a blog post yesterday about this, and I show how to perform major online upgrades with logical replication. Okay, and you can use the same technology to move away from IDS or from another operator or from a Postgres that is in VMs. Okay, so basically use the native logical replication of Postgres to collect changes that occur in a database and consume them with subscriptions. Okay. Another feature that we have introduced is spread rolling upgrades. So if you have several installations of the operator and you upgrade it, they can be spread, let's say every 30 seconds or so. Then another big feature that we are introducing the operator, it's actually a hidden feature, is CMPGI. CMPGI is CloudNativePG interface. We are trying to address the main concern that is very hard to develop or to write features for the operator. Okay, because it's complex. It's not an operator like the others. It is a failover management system, backup controller. It has Prometheus exporter and so on. Okay, so the idea is to enable everyone, including other vendors, to write plugins. Like, in Postgres, there are extensions. Timescale, for example, is an example of an extension. It's actually a company that is being built around an extension of Postgres. Okay, so the idea is to create kind of an ecosystem around CloudNativePG, and the first one is Barman Cloud. So Barman Cloud right now is part of the operator, and is the main solution that we use for continuous backup and recovery. We already have a plugin now, which is experimental, and that we will be launching together with 125. And you can use the plugin. So in the future, Barman Cloud will only be available as a plugin, community plugin. And so this is again another important thing that we're doing. Then I mentioned before volume group snapshot. It's been introduced in Kubernetes 132, and hopefully will be the first adopter of volume group snapshot officially in the database space. Then we want to add role resource, improve how we manage extensions, because right now, if you want an extension, you need to put it in the base image for Postgres, and then also have. So the idea is to change how Postgres manages extensions. Okay, to enable Postgres to add more directories that contain extensions, so that we can mount them as I think they're called volume source. It's a alpha feature in Kubernetes right now. Okay, so the idea is to mount extensions as additional volumes and make them available in the container. So this is what I view. Postgres started as on bare metal, and then VMs. I think Heroku, for example, when Heroku came out, it was using Postgres. Postgres became very popular because of the way it was being used in VMs. And I see a new opportunity now to start a new S-curve with Kubernetes. So again, better heads of elephants than cattle or pets. Okay, so this is how I'd like to define our strategy in Kubernetes. We are a special application, but as I said before, we'd like to be treated primarily on where we run. Okay, so the physical control rather than the logical one. So hopefully, you now understand that databases are #1 workloads in Kubernetes, that Postgres is the most popular database, CloudNativePG is the most popular operator. But for CloudNativePG, which we are still in phase 1, okay? Phase 1 is primarily the Divas adoption. I also see a lot of interest in moving away from VMs because of cost optimization. So what you can do is actually skip entirely VMs and install dedicate physical nodes, physical Kubernetes nodes for Postgres. So you bypass VM licenses as well, okay? And then you can take advantage of zero cutover migrations with logical replication and the subscription that we have introduced in 125 if you want to move data inside. I talked about the microservice approach, which will be the future, hopefully, and definitely the opportunities to achieve cloud neutrality now. And as a last thought, we're talking about complex stuff here. Okay, don't imagine that without knowing Kubernetes or without knowing Postgres, you can succeed. Okay, day two operations, okay, the operator performs them, but you still need to put a lot of attention in how your organizations are structured. So there's a great book. It's called Wiring the Winning Organization. I always mention that it's from Gene Kim, and talks about people, about the social circuitry that you need to create in an organization to solidify, simplify, and Kubernetes simplifies a lot and amplify what happens, okay? And I think for DBAs, if you're a DBA, build T-shaped profiles, so understand a bit of Kubernetes. You don't need to understand the entire Kubernetes because it's modular, but you need to be part of this change. It's a good change, and hopefully you'll be part of multidisciplinary teams, the stream-aligned teams I was mentioning before, to innovate in your organization and to be responsible to help everyone with Postgres. So this is, I want to thank all the other maintainers and all the contributors, users, and community members, and also obviously EDB, because I think donating the IP today is not something that happens very frequently, considering large organizations. But that's because we believe in the same model that Postgres has had for many years, and we want everyone to run Postgres. So don't forget the virtual cycle. I mean, open source software exists because there's companies that need to be helped and supported to support open source software. So thank you.
Thank you so much, Gab. And I really resonated how democratizing Postgres for everyone, and that's something I think also resonates to a lot of the crowd. And speaking about the crowd, sort of the participants count has gone up since you started speaking. So people are really interested in this topic. If you have a couple of minutes, we have some questions. Is that okay?
Yeah, sure. For me, it's fine.
Yeah. And there is one question from Anders, and here's a question: if you're familiar with test containers library for Java applications.
I'm not, but I'll write it down.
Yeah,
I'm not a big Java user or fan. That's my problem, but I'll check, I'll verify.
Yeah, I know, at least for my organization, I know that test containers is something that's used a lot there, and sort of if you have some thoughts on.
Okay, definitely. Yeah.
And then there was from Pedro. He has if it's possible for databases in different instances to communicate with each others. A little bit.
So there's actually an extension called Postgres Foreign Data Wrapper. Okay, so it's a Postgres capability. So right now, there's a plan for us to add declarative management for foreign data wrappers. I don't know if you're familiar with the operator. We've got a section called external clusters. So the idea is that you define external clusters that primarily you define a connection to another Postgres cluster. And then we should enable you to add what we call foreign servers, okay, in Postgres. So the idea is to use an extension that comes with Postgres. What I was mentioning before is called Postgres FTW, and you install it in the instance, and you define a foreign server in your database, and then you create foreign tables. So you can add foreign tables in your database that point to another database in another instance. So you can do it now, but imperatively. Okay. So I don't know. Another security measure of the operator is that by default we disable super user access. Okay. By default, you can only access with a standard user. Okay. What you need to do there is in order to create the foreign server, you need to run some commands as super user. So you might need to enable super user access, run the instructions, and remove it, or you connect directly in the pod and run them as one-off operation. But as I said, at the moment they're primarily imperative for the operator. It doesn't mean that you cannot also make them with Ansible or other tools at that point. Okay. I hope that answer. You can also connect to Oracle databases. There are extensions for that. Foreign data wrappers are generic, okay? So that you can find foreign data wrappers for pretty much everything. And the concept is, again, foreign tables. That's how they're called in Postgres. And you can create indexes. I mean, they're quite optimized, especially the Postgres one. It also supports transactions. So if you want, you can create a local transaction, write to another Postgres in another instance, and then roll back, and the transaction is rolled back. I mean, this is the cool thing about Postgres. And I laugh when I see people starting again with a new database today. Or they tell, oh, this is not cloud native. I mean, what do you mean? I mean, this is 30 years of innovation and robustness and a lot of features that are already there. And we might not even know, but this stuff has been around for more than 10 years and it works. Okay, so.
It's really, really cool. We have one more question. Let's try to keep it short, and that's the Spire, the Spiffy and Spire, and they have a PG helper for working with relatively
we want to
credentials. Wondering if that is sort of on the radar for Cloud Native.
Yeah, definitely. I mean, Spire, I mean, the whole workload identity stuff is something we want to improve. So in order to do that, for example, just to give you a bit of context, we need the role CID, okay? And then at that point, we would like to improve the integration with Spire and Spiffy in general.
That's so great to hear, and we could probably spend more time discussing and talk questions here, but I think we need to wrap this up. So again, thank you so much, Gab, and thank you so much to the EnterpriseDB team. I know that Nikolai has been here with us. We have Søren been there. There is in the chat, there is email to Søren, so he can also answer questions there. And thank you so much to the whole EnterpriseDB team.